Hi, this is Andrea Hendricks. We're going to talk about in this video how to find trig functions of any angle. We're going to evaluate trig functions of any angle, then we're going to use a reference angle to evaluate trig functions, so yet another way to evaluate trig functions, and then we're going to solve simple trig equations. So let me start by talking about evaluating trig functions of any angle. Prior to this point, we talked about trig functions from two different perspectives. We've talked about it from the perspective of the unit circle and also from the perspective of right triangles. When talking about it from the unit circle, we were looking at points on the terminal side of the angle whose distance from the origin to that point was 1, right? Because the radius of the unit circle is 1. So that's where we were looking at the hypotenuse of the triangle was really 1, if you will. Well, when we talked about trig functions from the perspective of right triangles, we were restricted to talking about acute angles, right? Because the sum of those other two angles in the right triangle had to be less than 90 degrees. Well, now we're going to extend this discussion to talk about any angles and actually any points that are not on the unit circle. So let's look at this picture here. If we have a point xy that lies on a circle still centered at the origin with radius r, so if you want to think about a circle through that point xy, you can, then we know the standard form of the equation holds true, right? That x squared plus y squared is equal to r squared, which if we solve for r, we would get r is equal to the square root of x squared plus y squared, where x and y both cannot be 0, of course. Well, if we think about trying to reduce this to a circle with radius 1, right, instead of r, well, we would have to divide our radius r by r to get a unit circle. Well, if we divide the radius by r, we also have to divide the points xy by r to get it to the point that's on a circle with radius 1. Okay? So if we divide everything by r, then we get a point that is on the unit circle. And it's kind of like proportional circles, proportional angles, right? Because we haven't changed the angle in that way. We've only changed the point that lies on the terminal side. So instead of thinking about the side with radius r, we can think about now a side with radius 1. And then the sine and cosine values are exactly what you know them to be. They are the y value of the point that's on the unit circle and the x value that's on the point that's on the unit circle. So in this case, sine theta would be y over r, cosine theta would be x over r. So the key thing is it has to be on the unit circle. Well, if you don't like that explanation, if you will, we can think about it in terms of the right triangle. If we think about extending down a perpendicular line to make that a right angle and talk about this as theta prime instead of theta, but since they share the terminal side of the angle, then they're going to have the same sine and cosine values. Well, if this is a point xy up here, so think about me just bringing this down, then we know our radius is the hypotenuse. Well, this would have to be x and y. So sine theta would be opposite over hypotenuse, which would be y over r. Cosine would be x over r, and everything else is the same. So it's kind of another perspective of seeing how we can get this y over r and x over r. So why is this important? Because now we're not restricted to just unit circles, so we can divide it by the radius and get it really to the point that's on the unit circle. We're also not restricted to just acute angles. We can let theta be any angle that we want it to be. So let's talk about this with some particular examples. If we want to determine the exact values of the trig functions for the angle where the point given is on the terminal side of the angle that's in standard position. So here we have our Cartesian coordinate system. We have the initial side of the angle on the x-axis. We have a point 815, and I'm just going to approximate here. So we have the terminal side of the angle going through this point 815, and we need to find sine, cosine, and theta, and so on of this angle. Well, we know the formula that would allow us to get what the value of r is. R is going to be the square root of x squared plus y squared, so that's 8 squared plus 15 squared, which in this case would be the square root of, 64 plus 225. 64 plus 225 is 289, and the square root of that is 17. So now we can find out what the sine of theta would be. Sine of theta is equal to y over r, which in this case would be 15 over 17. Cosine theta is equal to x over r, which would be 8 over 17. Tangent of theta would be sine over cosine, or y over x, which would be 15 over 8. Then we can do the reciprocal functions. Let me change the colors here. If we have cosecant of theta is a reciprocal of sine, so that would be 17 over 15. Secant of theta is a reciprocal of cosine, which is 17 over 8. And lastly, cotangent of theta is 8 over 15. So knowing a point on the terminal side, we can determine what the trig functions are for that angle. Now here's another example. If we have the point 3, negative 9, so the point 3, negative 9 is somewhere down in the fourth quadrant. So we have the terminal side of the angle going through this point. So here's our angle. So if we want to find the trig functions, we need to first find out what the radius r is from the origin to this point. So r would be equal to the square root of 3 squared plus negative 9 squared, which is what, 9 plus 81, or 90. We can simplify that because that's really 9 times 10 to be 3 on the square root of 10. So now sine theta is equal to y over r. So that would be negative 9 over 3 on the square root of 10. And we can reduce that. That's really negative 3 over the square root of 10. And multiplying by the square root of 10 over the square root of 10, we would get negative 3 on the square root of 10 over 10. Now, cosine theta would be x over r, so that's really 3 over 3 on the square root of 10, which would be 1 over the square root of 10. Multiplying by the square root of 10 over square root of 10, we would get square root of 10 over 10. And then what else do we need to find? Tangent of theta is y over x, so negative 9 over 3, which reduces to negative 3. And now their reciprocals. Cosecant theta is the reciprocal of sine. I would probably do it from this form because then we would not have any radicals in the denominator, so that would be the negative square root of 10 over 3. And secant theta is the reciprocal of cosine. So again, taking the reciprocal of 1 over the square root of 10 would just be square root of 10 over 1, or square root of 10. And lastly, cotangent of theta is going to be the reciprocal of negative 3, which would be a negative 1/3. So the key is finding the value of r by using the form of the circle, x squared plus y squared equals r squared. So solving for r is the square root of x squared plus y squared. And then dividing the x and y values by that to get the sine, cosine, and then the other functions are pretty much straightforward from what you've learned thus far. So if you have any questions on that, please don't hesitate to contact me. Thanks. Let's look at another example here where we want to find the values of the 6 trig functions given the information. Now here we're told the sine of theta is 3 over 5 and theta lies in quadrant 2. So this is a little bit different. In the previous example we were told the point on the terminal side of the angle. Well, knowing the sine, we can actually figure out what the point is on the terminal side of the angle because we know what sine is. It's y over r. So we know that y over r is equal to 3 over 5. Now, why are we told the information about the angle? Well, knowing where the angle lies tells us what the signs of x and y are. So if theta is in quadrant 2, that tells us that we're going to have a negative for our x value and a positive for the y value. Well, we also know the relationship between x, y, and r. We know that x squared plus y squared is equal to r squared. So knowing this relationship will allow us to figure out what x is, so then we can find the other trig functions. So we have x squared plus 3 squared is equal to 5 squared. So we have x squared plus 9 is equal to 25. So therefore x squared is equal to 16. Now typically you think, oh, well, x is just equal to 4, but remember the signs here, because we have the x squared equals 16, so x is equal to plus or minus the square root of 16, which is plus or minus 4. Well, knowing that theta is in quadrant 2 tells us that theta has, or x rather, has to be negative 4. So x is negative 4, and now we know what y is. It's 3, and r is 5. So we knew sine theta was 3 over 5. Well, cosine theta would be what? X over r, which is negative 4 over 5. Tangent of theta is equal to y over x, or sine over cosine, which is 3 over negative 4, or negative 3/4. And then we have the reciprocal of sine, which is cosecant. So cosecant of theta is going to be 5/3. The reciprocal of cosine is secant of theta, which is negative 5 over 4. And lastly, cotangent of theta would be negative 4 over 3. Okay. Now, here we have secant theta is equal to negative 2, and 0 is less than theta is less than pi. So 0 less than theta less than pi tells us our angle is in either what? Yeah, quadrant 1 or quadrant 2. Well, to be in quadrant 1 or quadrant 2, x could either be plus or minus, we don't know, but y has to be positive there. Well, hopefully knowing what secant of theta is will tell us what x is going to be. Well, I think in terms of sine and cosine, so if I can convert the problem to either sine or cosine, it makes it a little bit easier for me. Secant of theta is negative 2, which means that secant is really the reciprocal of what? Yeah, cosine. So cosine theta has to be negative 1/2. So we can think about this as really negative 1 over 2. So, well, cosine was what? X over r. So this tells us that x is negative 1 and r is 2. R is a radius, so r is always positive, so you never let the denominator be negative in this case. So now we can figure out what y has to be. So we would have negative 1 squared plus y squared is equal to r squared. So negative 1 squared is 1 plus y squared is equal to 4. So y squared is equal to 3. So y is going to be plus or minus the square root of 3. But we know y has to be positive in the first or second quadrant, so that tells us y has to be just the square root of 3. So x is negative 1, r is 2, and y we just found to be the square root of 3. So knowing cosine allowed us to figure out the rest of the trig functions, because now we can figure out what sine of theta is. Sine theta would be y over x, which would be the square root of 3 over, I said y over x, I'm sorry, y over r, square root of 3 over 2. Tangent of theta is our y over x, so the square root of 3 over negative 1, or negative square root of 3. And the reciprocal of sine is cosecant of theta, which would be 2 over the square root of 3, which we can rationalize to get 2 times the square root of 3 over 3. Secant of theta is the reciprocal of cosine, which we already knew, which is negative 2. And then cotangent of theta, so reciprocal of tangent, so that was going to be negative 1 over the square root of 3, and rationalizing that as negative square root of 3 over 3. Okay? Now, you might think, I know another way to do this. Do you remember in talking about right triangles, we knew the relationship that, what? Cosine squared plus sine squared is equal to 1. So you could use that fact together with the rules about the sines to determine what the other trig functions are. So that's another way to go about it as well. But if you have any questions, please don't hesitate to contact me. Thanks.